This is an advanced lesson for using 2DXY site survey tools, the SketchUp extension for drawing property boundaries or site surveys. If you haven't watched the basic lesson, please stop and do that first because this won't mean much to you. In this lesson we have 4 topics to cover. First, an explanation of how SiteSurvey generates dimensional text that's proportional to your survey. Then we'll cover how to draw non-tangent arcs. The basic lesson covered only arcs that were tangent to a bearing or another arc. Thirdly, we'll cover how area is calculated by this extension. And finally, how to design a property subdivision. Surveys generally require much larger dimension text than other types of drawings, and a 300-foot bearing usually requires larger text than a 120-foot bearing. So beginning in version 3.0 of 2DXY SiteSurvey, all newly added text for bearings and arcs are added in a proportion to the length of the bearing or the length of the arc chord. A similar thing is done for the area labels for properties. They get larger as the property width and height get larger. This saves a lot of futzing with the normal SketchUp dialog boxes for setting text height, but you can change the text elements after they've been added. So I can select this dimension, let's say, and let's say this one, and using the entity info box change its font, let's say, to Times New Roman and from 7 feet to 10 feet. That will change it, and any further edits of that bearing, let's say to make it shorter, 78 feet, will retain the font characteristics that were previously set. Similarly, for the area labels, if you have a hard time selecting them, sometimes SketchUp wants to select the face rather than the text, so easy way around that is to click on the area button here, just hit OK, and that leaves the text selected. And now I can go and change the font of that also to Times New Roman if I want. And because it's selected, I can also move it around to wherever in the lot there's it doesn't interfere with buildings or other things you're drawing. A couple of other features with dimensions: you can select any number of dimensions, 1 or more, and right click on it to wrap the dimension. Maybe you want to fit it on a smaller length, or unwrap it, or flip it to the other side of the bearing line, or flip it back. Finally, it's important to remember that all dimension elements are put in a special layer, 2DXY Survey Dimensions, and can be easily turned on and off at will while you're working. Probably 90% of all surveys might look like this one on the left, which is made up entirely of straight line bearings, no arcs at all. Of the rest, most of those that have arcs, the arcs are tangent to the bearings. This property has just one arc, defined probably by a roadway, curving roadway that passes by it. And we addressed how to add arcs that are tangent to bearings and arcs that are tangent to other arcs in the basic lesson. But there are rare cases, there are not not too many, that where you need to draw an arc that's not tangent to a bearing in your property. So I'm going to show you 4 different cases that come up. The first one, you see the arc here as we're drawing the traverse clockwise. We come to an arc that is not tangent to the bearing we're drawing. I'm drawing it over here, and however in this case we see that the bearing is tangent to some other property boundary that's on our survey drawing, some neighboring property. And so what we need to do to draw this, or the way we recommend to draw this, is to first draw this external bearing. To do that, we'll just draw a line over here somewhere, and then we're going to select it, edit it. This bearing is north 85 degrees, 0 minutes, 0 seconds east, 76 feet, although that's actually not too relevant here. And there it is. So now we need to move it. Take that endpoint here, attach it to that one, and now we can add a bearing. Oh, I'm sorry, add a arc, a tangent arc, using the length of 57.6. A radius of 55 feet, and there it is. So now we can continue with the rest of the boundary. South 35, 00055, and so on. So we've drawn that arc using the tangent arc command, because we found an external bearing that was tangent to it. Sometimes you might have an external arc which also needs a bearing before it, so you'd have to draw the bearing and the arc, move it to be located at the end of this bearing, and then draw a tangent arc from there. Now, in other cases where we might not have an external bearing, but we can see that, and we're lucky in this case, the arc is tangent to the next bearing after the arc. So we're drawing this clockwise, but we need to jump to this bearing. So if we draw that bearing first, off in space, we'll edit it. It's south 35, 0, 0, and 55. There it is. And its start is here and its end is here, so if I add an arc tangent to it, the arc is going to be down here. But in this case, what I want to do is draw the arc going back this way. So what I need to do first, and this is a new feature in version 3.0, right click on that bearing and reverse it. This is a new context command for bearing. So that reverses the bearing, so the starting point is here, the ending point is there. Now I can do my tangent arc, which is 57.6 arc length and radius 55 again. And we didn't do it the right direction, so we'll do that again. .6. it's to the left from this direction. And now I can select this arc, all connected, and move it to connect to that point. So now we want to continue on down this way, so we have to reverse this one back so we can draw below it. So I'm now going to reverse the bearing again, and now I can add a bearing below it that corresponds to this one here, south 21, 23, 12, west for 42.35. And so on. So we've drawn our non-tangent arc by going at it from the other side. The third case involves a situation where the orientation of the arc is defined by a temporary bearing or a special bearing that shows that ends at the center of the arc. So in version 3.0 we've added a new tool for adding arcs using a bearing that defines its radius. So to use that tool we have to first draw the temporary bearing. Let me just zoom in here a little bit. You select this bearing, add a new bearing with these characteristics. It has to go south 5 degrees, 0 minutes, 0 seconds, east, and for a distance of 55. That defines the center point of the new arc. So to use this new tool, you have that radius bearing selected, and up comes this arc box. It already has the 55. Our arc length, I've got to go back to look at our arc length. It's 57.6, so really the same as you had before. And the arc is curving from the right from the start of the arc, so there it is. So that converts or replaces this bearing with the arc. It leaves the dimension defining that radius for a reference point, but it deletes the bearing, because in some cases you have bearings that are very long and that would interfere and overlap, intersect with other parts of the property. So this R on the tool means replace. We're replacing the temporary radius bearing with its arc. So the last case is where you have an arc that's defined by its chord bearing. So here we have an arc that's labeled with a bearing. So what we have to do first is to draw that bearing temporarily. Regular bearing. It's south 65, 0, 0, and we aren't given the chord length, but that's fine. We can just put in some arbitrary length, let's say 40 feet, so it's out of our way. So this is a temporary bearing that has the same bearing as the chord of this arc, and our tool here for replacing a chord bearing with its arc will do that. So we want an arc that has a radius of 55, that curves to the right, has a length of arc length of 57.6, and defined by the arc length. So we didn't need to have the chord length, as sometimes surveyors don't give you that, but the bearing will define its orientation. So that replaced the temporary bearing with the arc that whose chord has that bearing, and the label for the arc includes in it, for reference, the bearing of the chord, the arc length and radius that defined it. Even though we didn't know, we could have, if they gave us the chord length, we could have used that, but we didn't. We don't need it. So we've seen these two new arc tools, the replace the radius bearing with an arc, replace the chord bearing with an arc. They both are added in version 3.0. You may never in your life come up against any of these, but if you do, as a couple of my customers have, these tools will save your day. I want to talk briefly about the area function here, because this area calculation that I implement in the area command here gives you true area of properties that have arc boundaries. And that's only worth mentioning because SketchUp normally doesn't do that. So I'm going to show you an example of the difference. Here I've drawn 2 100-foot circles, and 100-foot radius circles, and one of them I'm going to, you can see by selecting it, SketchUp knows it's a circle, but I'm going to reduce the number of segments here just to better visualize what's going on. So SketchUp knows these are both circles, but we'll see how differently it treats them as far as area is concerned. If I select either one of these and apply my area command, you get 31,416. Now, since this is pi r squared is the area, so radius squared is 10,000 times pi. Notice this looks very familiar. 31,416 is 10,000 times pi. And if I do the same thing here, I'll get the same number. Now contrast that with what SketchUp does. If I select the leader text command and put it on this face, I get an area of 31,058. And if I put it on this face, I get an area of 29,389. So what SketchUp is doing is only computing the area within the straight line arc segments. For normal use in SketchUp, where you're using areas to calculate materials of usually rectangular floors or walls, it doesn't matter. But for properties that are large, that have large arc segments, the difference is potentially significant because this is your legal basis for the maximum coverage of the site. And if you don't have the correct area, you can be forced into going for a zoning variance if you exceed your coverage. So it's very much more important to have these areas exactly correct. And that's what the area function in the 2DXY site survey tool does. Lastly, I'm going to show a slightly different use for these tools, where if I have a client who has a larger property. It's not in metric, but I did this in metric just as an illustration of using metric in this extension. And he wants to subdivide this up into a number of parcels. And so in this case, I've created a group that's includes I've drawn a roadway right-of-way. This is not the road itself, it's the property boundaries or the frontages and the right-of-way of the road that's needed. And what I need to do is to now, probably several schemes, divide this up into reasonable size plots. So using the tape measure tool, I'm just going to establish a 15-foot width of these first couple lots, and using the regular line tool I can draw the boundaries of these lots. Obviously I'd take much more care in doing this exactly in designing the real lots, but as an illustration I'm going to show less care. That's not connected. Let me make it connected. Alright, so now that we have our parcels, each one is a separate polygonal area, I can calculate their area. After you calculate each one, it's selected so you can easily move it if you want. But the important thing to know too is that you can select each one of these boundaries and just edit them and accept them. Edit, OK. In order to dimension all of the boundaries of every lot in proper survey notation, so we can keep going over the entire subdivision. And have every boundary properly annotated in survey notation in only a few minutes. So you can keep going and doing that, but so this is an example of where you're not starting with a surveyor's drawing and trying to replicate it. You're trying to do a drawing of your own and then annotating it with proper survey notation. So that's the end of this second video. Take a look at the extension on the extension warehouse. Try it out, and I'm sure that if you do the kind of work I do, it will pay for itself the first time you use it. Thanks for watching, and I'll wish you a very good day.